Hi, today is an exciting day because we are going to compile and actually run an Agda program, which is something that doesn't happen every day. So let's take a look. So the way we do this is we define a main function, it has to be called exactly main, and it has to have type exactly primitive IO of the unit type. So what is this? Let's go and look at the primitive IO. And we see that it's really coming down to this Agda built-in IO, which is a very Spartan module. It's basically just postulating that there is such a thing as I/O, which given a set gives us a set at any level, A. And the important thing is that it's first of all declared to be a special I/O thing, which is built in. And secondly, we are explaining how to compile it, because that's what we really care about. Right? So the I/O that we have is not going to run when we type check things. We're not going to print things or read things or launch any missiles when we type check things. That's going to happen when we actually run the program. So that's why it's important that we know how to compile it. So that's the primitive I/O, but that's not very user-friendly to use. So on top of that, there is this layer of more friendly I/O, which goes back to the base module with defined here, and it has all the things we might want. So it has a return, a bind, a sequence of things, and then on top of that, there's also an fmap function and the bind that we are actually going to use. And importantly, there is a run function that takes a user-friendly I/O and turns it into a primitive I/O. Right. So whenever we write an I/O program, then we are basically always going to follow this pattern that we start by running not the primitive I/O, but a user-friendly I/O, and then we're going to immediately do a do block, which means that here we can give a sequence of instructions, and they are going to desugar to this bind thing. So what I had in mind for today was I thought it could be fun to write a little program that will read in the source code of some file, or the source of some file, and print it out again with line numbers. So let's do that. So the first thing we want to do is we want to read a file. So I'm going to say bind the result of read finite file. And then here I have to give a file name. So this read finite file is defined as one of the friendly things in the IO module. So I'm going to give the file name of the file I'm writing just for fun. So that's going to be lectures/line numbers.agda. Okay, so I'm going to read in my own source code. And then next, I can say that the lines in this file are given by the lines function, which is defined in data.string. Right. So this, if I now look in my whole, gives me a list of strings, which are all the lines in the file. So this is how I often do this in the do block. I don't actually work in the whole, I just add in one more line on top of it, because the whole machinery does not work very well with the desugaring of the bind, etc. So, okay, I have the lines. Now I would like to have the numbers that I want to print in front of it. So I'm going to say numbers equals, and then thankfully there is an up to function in data list, which counts up from 0 to a given number. So here I want to count up to the length of L, right? So I get one number for every line, and then this is going to start counting from 0. So I want to start counting from 1, so I'm going to add the successor to all of this. And I'm going to say it's the natural number successor, because I have more around. Okay, so what we have now is we have a list of numbers, and further down we have a list of strings. Right? So now we can let our new lines, not to be confused with new lines, line breaks, be the result of zipping together these two things, right? So that means that we're going to take element by element and put them together into a pair of things in a list. So we see that indeed the new lines here is a list of pairs of a number and a string. So next, I don't actually want to have a pair and a number of a string. I want to print it out as a string again, right? So for each element here, I'm going to map over it with some function. And Agda knows that this must be a function from pairs of numbers and strings into something. And this is yellow because Agda does not know what something I want here, but I know that I want a string. So I'm going to start writing this function, get a line number, and I get the contents of the line. And then here now I want to produce a string. So the first thing I'm going to do, I'm going to show this number. I have data not show. I will do exactly that. If I show n, that's giving me a string. And then I will append something else to it. I will have a colon and a space. I will append some more things, namely the actual contents of the line. And that's going to be a string. So new lines here now, after that mapping, is a list of strings. So if I use the unlines functions from data string again, then that is going to take my list of strings and concatenate them all together with a line break in between. So this is going to give me a string, and then I can finally just print that string out. And that's going to give me an IO unit because I don't care about the value I get, I only care about the side effect of printing it out. Okay, so that type checks. Let's actually compile it. So I go to the Agda menu, I choose compile. I have to choose the backend. I can press tab if I want, and the one I want is the GAC backend. So now it's compiling it with that. It's linking it. It was successfully compiled. So if I look here in my directory, I see that I now have a line numbers program. So let's run that. And we see that indeed it has printed out the source code that we just wrote, but with some line numbers added to the front. That's quite cool. Right. Hooray.